everyone. Mathematics is the gate and key of the science. Neglect of mathematics works injury to all knowledge, since one who is ignorant of it cannot know the other science or the things of this world. In your textbook, take page number 156. Learning objectives. Sum rule, product rule, inclusion-exclusion principle. Combinotarics and mathematical induction. Now let us learn a basic counting principle which happens to be the highlight of this chapter and is an important concept, so please concentrate. Sum rule. Let us consider two tasks which need to be completed. If the first task can be completed in m different ways and the second in n different ways, and if this cannot be performed simultaneously, then there are m plus n ways of doing either task. This is the sum rule of counting. Next case, product rule. Let us suppose that a task comprises of two procedures. If the first procedure can be completed in m different ways and the second procedure can be done in n different ways after the first procedure is done, then the total number of ways of completing the task is m into n. Now I will explain how to find sum and product rule with the help of example. Assume I am walking into a restaurant that sells pizzas and burgers. There are 4 different types of pizzas and 3 different types of burgers. And I plan to eat one item only, whether pizza or burger. So I have 4 varieties to choose from pizza or 3 varieties from burger. So in total I can order one of these 7 items, one of these 4 plus 3, 7 items. Let me now change this problem. I decided to buy myself one pizza and one burger. Okay, it's not just one item but 2 items. But I am sure I will be buying one pizza and one burger. In how many ways can I make my order? First option, one pizza, one burger. That is first pizza and first burger. First pizza, second burger. Possible a second option. First pizza, third burger, third option. Similarly, second pizza, first burger. Second pizza, second burger. Second pizza, third burger. So on and so forth. So in how many ways I can make my order? Clearly it is 4 times 3, which is equal to 12. Please remember, last time it was 4 plus 3. Last time it was 4 plus 3, that is 7. This time 4 into 3 is equal to 12. So it is only commonsensical to know when to add and when to multiply. Previous case was addition, this case was multiplication. Previous case we have OR. If you have OR, we have to add it. If you have AND, then we have to multiply. This goes by the title rule of sum and rule of product. The inclusion-exclusion principle. Suppose two tasks A and B can be performed simultaneously. Let n of A and n of b represents the number of ways of performing the task A and B independent of each other. Also, let n of A intersection B be the number of ways of performing the two tasks simultaneously. We cannot use the sum rule to count the number of ways of performing one of the tasks, as that could lead to overcounting. To obtain the correct number of ways, we add the number of ways of performing each of the two tasks and then subtract the number of ways of doing both the tasks simultaneously. This method is referred to as the principle of inclusion-exclusion. Using the notations of set theory, we write it as n of A union B equal to n of A plus n of B minus n of A intersection B. In order to count the number of elements in the union of two sets A and B, we need to know the number of items in set A, number of items in set B, and the number of items in both A and B, that is intersection of A and B. Simply adding the elements in A and B together will count the elements in the intersection twice. So, we need to subtract the intersection of A and B in order to obtain the correct number of elements in the union of A and B. This concept can be stated using the mathematical formula, that is n of A union B equal to n of A plus n of B minus n of A intersection B.
Math puzzle is a good exercise for your thinking skill. Now, I am going to test your thinking skill. Rule for this puzzle is draw 9 dots as shown. Your task is to go through all the dots using only 4 straight lines. The next line has to start where the last one ended. For example, now I am going to draw lines from this dot. So I will get like this: second straight line, next third straight line, then fourth straight line. Now one dot is remaining. So this method is wrong. Okay, try this. At the end of the session, I will explain the answer for this puzzle. Now let us see some example sums. Example 4.1. Suppose one girl or one boy has to be selected for a competition from a class comprising 17 boys and 29 girls. In how many different ways can this selection be made? Here we have number of boys. Here we have number of boys is 17. Number of girls is 29. Here we need to select one girl or one boy. The option is R. Already I told you, if you have the option R, then we need to add. The first task of selecting a girl can be done in 29 ways. The second task of selecting a boy can be done in 17 ways. It follows the sum rule. Then there are 17 plus 29. 17 plus 29 is 46. 46 ways of making this selection. Here the main concept is R. Since we have R option, we need to add. That we have to keep it in mind. Example 4.2. Consider the three cities Chennai, Trichy and Tirunelveli. In order to reach Tirunelveli from Chennai, one has to pass through Trichy. There are two roads connecting Chennai with Trichy, and there are three roads connecting Trichy with Tirunelveli. What are the total number of ways of travelling from Chennai to Tirunelveli. There are two roads connecting from Chennai to Trichy. Let us name them R1 and R2. Further, there are three roads connecting from Trichy to Tirunelveli. Let us name them as S1, S2 and S3. Suppose a person choose R1 to travel from Chennai to Trichy and may further choose any one of the three roads S1, S2 or S3 to reach from Trichy to Tirunelveli. Thus the possible road choice are R1, S1, R1, S1, R1, S2, R1, S2, R1, S3. Similarly, if the person choose R2 to travel from Chennai to Trichy, the choices would be R2, S1, R2, S2, R2, S3. So, there are two roads from Chennai to Trichy. So, 2 and here we have the option is and. And means what do you need to do? We need to multiply into 3 roads from Trichy to Tirunelveli. So, into 3. 2 into 3 is 6. 6 ways of traveling. 6 ways of traveling from Chennai to Tirunelveli. So we got R1, S1, one possible way, R2, S2, 2, R1, S3, 3, R2, S1, 4, R2, S2, 5, R2, S3, 6. So total number of ways is 6. 6 ways of traveling from Chennai to Tirunelveli. Example 4.3. A school library has 75 books on mathematics, 35 books on physics. Number of books in maths is 75. Number of books in physics is 35. A student can choose only one book. In how many ways a student can choose a book on mathematics or physics? Here we have the option is R. That means we need to add maths book and physics books. A student can choose a mathematics books in 75 different ways. A student can choose a physics books in 35 different ways. Hence, applying the rule of sum, number of ways a student can choose a book is 75 plus 35. 75 plus 35 is 110. Example 4.4. In a village, out of the total number of people, 80% of the people own coconut groves and 65% of the people own paddy fields. What is the minimum percentage of the people own both? Let N of C denote the percentage of people who own the coconut groves. So, N of C is 80 and N of P denote the percentage of people who own the paddy fields. That is N of P equal to 65%. The maximum value of N of C union P is 100. The minimum value of N of C intersection P need to find. By the rule of inclusion exclusion, n of C intersection P equal to n of C plus n of P minus n of C union P. Here n of C is given as 80 plus n of P is 65 and n of C union P is 100. 80 plus 65 is 145 minus 100. 145 minus 100 is 45. That is, for minimum percentage of the people who own both is 45. Example 4.5. Find the number of strings of length 4 which can be formed using the letters of the word bird B-I-R-D without repetition of the letters. The condition is without repetition. Strings of length 4 is given. So here we have 4 elements. Here we need to use the letters B-I-R-D. There are as many strings as filling the 4 vacant places by the 4 letters. Keeping in mind that repetition is not allowed. The first place can be filled in 4 different ways by any one of the letters B, I, or D. For example, I have taken D. Following which the second place can be filled by any one of the remaining letters. So already I have taken D. So remaining 3 letters we have B, I, R. So for example I have taken R. So we have the remaining letter as B and I. Following which the third place can be filled in 2 different ways. So for example I have taken I here. Then remaining only 1 letter following which 4th place can be filled in 1 way, that is B. Therefore, the number of ways in which the 4th place can be filled by the rule of product, that is 4 into 3 into 2 into 1 is equal to 24. Hence, the required number of strings is 24. Example 4.6. Find the total number of outcomes when 5 coins are tossed once. So assume the coins as coin 1, coin 2, coin 3, coin 4, coin 5. When a coin is tossed, the outcomes are in 2 ways, which are head, tail. So each coin has 2 options. So 2 into 2 into 2 into 2, which is equal to 2 power 5. By the rule of the product, the number of outcomes when 5 coin is tossed is 2 power 5. 2 power 5 is 32. Example 4.7. There are 10 bulbs in a room. Each one of them can be operated independently. Find the number of ways in which the room can be illuminated. Each of the 10 bulbs are operated independently, means that each bulb can be operated in 2 ways. So here we have bulb 1, bulb 2, bulb 3, bulb 4, bulb 5, bulb 6, bulb 7, bulb 8, bulb 9, bulb 10. Each bulb has on or off mode. So each bulb has 2 options, that is off mode or on mode. The total number of doing this are 2 power 10, which includes the case in which 10 bulbs are off. Keeping all the 10 bulbs in off mode, the room cannot be illuminated. Hence, the total number of ways total number of ways equal to 2 power 10 minus 1. 2 power 10 is, that is 2 into 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 2. 2 twos are 4, 4 twos are 8, 8 twos are 16, 16 twos are 32, 32 twos are 64, 64 twos are 128, 128 twos are 256, 256 twos are 512, 512 into 2 is 1024 minus 1, which is equal to 1023. Okay, did anybody solve this puzzle? Now I am going to join these dots by using only 4 straight lines without lifting my hand. So join these 3 dots and extend the line. And join these 2 dots. And again you have to come like this and you have to end this way. Okay, this is the correct method. Wow, that absolutely astonishing. Thank you students. Practice all the problems and do the given homework. We'll meet you in the next session.